Maths Expo Desk, a division of Science Lecture Theatre, present problem number 12 in the Problem Solver playlist. I am your lecturer, Professor E.O. Efa. The problem: evaluate limit n factorial over n to power n, all raised to power 1 all over n, as n tends to infinity. Pause and try solving the problem on your own. You need help? Then continue watching the video for the solution. The solution. We recall the Stirling formula: n factorial equal to n to power n exponent minus n root 2n pi. Upon dividing both sides by n to power n, we have n factorial over n to power n is equal to exponent minus n root 2n pi. Now, raising both sides to power 1 all over n, this will give us n factorial over n to power n all raised to power 1 over n is equal to exponent minus 1 root 2n pi all raised to power 1 all over n. And this is equal to exponent minus 1 root 2 pi all raised to power 1 all over n times root n raised to power 1 all over n. Now, taking limit of both sides as n tends to infinity, we have limit of n factorial over n to power n raised to power 1 all over n as n tends to infinity is equal to exponent minus 1 limit root 2 pi raised to power 1 all over n as n tends to infinity times limit root n raised to power 1 all over n as n tends to infinity. We are now left to evaluate these two limits. Limit root 2 pi raised to power 1 over n as n tends to infinity is equal to 1. Since as n tends to infinity, 1 all over n will tend to 0, and root 2 pi raised to power 0 will give us 1. Also, we note that root n all raised to power 1 over n can be expressed as root n raised to power 1 all over n. And n raised to power 1 over n, we note, is a decreasing sequence for n greater than or equal to 3. And it is also bounded from below. That is, n raised to power 1 over n is greater than or equals to 1. Since n to power 1 over n is a decreasing sequence and it is bounded below by 1, it follows that the limit of root n raised to power 1 over n as n tends to infinity is equal to 1. This will then give us our limit to be limit n factorial over n to power n raised to power 1 all over n as n tends to infinity is equal to exponent minus 1. Let us illustrate this graphically as follows. The graph of f of n equals to n to power 1 all over n is as shown below. As we can see in this graph, at n equals to 1, f of n is equal to 1. At n equals to 2, f of n is 1.2. But starting from n equals to 3 to infinity, as we can see, f of n is tending to 1. So the limit of n raised to power 1 all over n as n tends to infinity is equal to 1. This also shows the graph of n factorial all over n to power n raised to power 1 all over n. This is the graph. As you can see, that function is tending to a value 1 all over e, which is equal to e raised to power minus 1 as shown previously. We have come to the end of problem 12. Thank you for watching, and keep on watching. I remain your lecturer, Professor E.O. Ifan.